2019年，诺贝尔物理学奖授予了3位科学家，以表彰他们在宇宙学和地外行星相关领域的研究贡献。那这期视频，我邀请到了其中一位诺奖得主 Michel Mayor。他因为发现了第一颗系外行星而获此殊荣。那这一发现让人类重新认识了自身在宇宙中的位置，并且开启了天文学的革命。时至今日，关于太阳系外行星的研究已经成为了天文学中非常热门的一个方向。那接下来我们就和 Michel 一块来聊一下他发现第一颗系外行星背后的故事。
My name is Michel Mayor. I'm professor of astrophysics emeritus here in the Geneva Observatory. So I did my PhD long time ago in 71, but no, I'm still extremely curious in science. I'm continually coming here to work. Evidently, from 26 years, I'm completely interested by the same topics, the new field of extrasolar planet.
根据 NASA 系外行星档案库的数据，截止到2022年6月27日，人类已经确认发现了5054颗系外行星，并且还有一大批的候选天体还在等待确认中。那么在100年前的科学界，天文学家是否已经意识到除了地球之外，我们宇宙中还有这么多的行星呢？
During the first part of the 20th century, most important astronomers like James and others predict the estimated number of planetary systems we could have in the Milky Way. And the number was never not known, or only maybe a few. It was nothing. So like 200 billion of stars and no planetary system except us.
当时的主流观点是，行星源于恒星间互相碰撞所产生的物质盘。然而恒星碰撞在浩瀚的宇宙中是概率极小的事件，所以这解释了为什么当时多数的科学家认为银河系内只存在极少数的系外行星。
And then after in 1952, Otto Struve published a short letter. It's not a big paper, it's a short letter. Say, all the low mass stars, the sun and below, are slow rotators. But if you have the collapse of big cloud, you always expect a huge excess of angular momentum. Where is the angular momentum? And I say, this is probably stored in a disk of matter, fastly rotating around, and this is the place to form the planet.
注意，只要听明白了这一部分内容，那距离获得诺奖就仅有一步之遥了。那100年前的科学家认为，在整个恒星系统形成的过程中，根据守恒原则，吸积盘，也就是后来我们所熟知的圆柱行星盘所含有的角动量会转化到恒星上，那这就致使了恒星的旋转速度会非常快。但当时发现的恒星呢，绝大部分以慢速自旋为主。所以 Otto Struve 提出，在吸积盘坍塌到恒星的过程中呢，会有行星的形成。行星的公转运动吸收了多余的角动量，使得最终中央恒星自身旋转的速度没有那么快。那这样的理论解释呢，就与当时的观测结果相符了。自然而然，像太阳系这样包含了行星的系统，那在宇宙中呢，应该是非常普遍的一个现象。
And immediately the mind of people change, the paradigm, and if you have a plot, you can see that after 1952 it jumped to billion, hundred of billion of planetary system, because it's a normal byproduct of the formation of planetary system. So a priori we can say every star should have planetary system.
这一新理论出现呢，使得天文学家的观念就发生了转变。那他们认为几乎所有的恒星都有围绕其环绕的行星，但是从技术上来说，探测到这些环绕系统是一件几乎不可能的事情。那想象一下，太阳系内距离我们最远的海王星，那它在天空中的大小呢，就相当于我们在5公里外看一颗硬币的大小，那仅是夜空中的一个亮点而已。当我们需要观测太阳系以外的行星时，那随着距离的增加，那亮点的亮度呢也会逐渐变暗，那逐渐超出了我们可视的范围。所以对太阳系外行星直接成像， 在那个年代就完全不可能实现。那如何才能发现一颗系外行星呢？100年前，人类对经典物理学的理解起到了关键的作用。
First technique, having not given any results, was that if you have a star like this, you have a planet orbiting around, but you cannot see the planet, but you can expect to see a small wobble of the position of the star on the sky. And this is called astrometric technique.
天体系统运动是围绕其质量的中心，而非恒星的中心。那受到行星运动的拖拽，那恒星在天空中的位置呢，也会发生扰动。这些扰动的大小和行星的一些物理属性，比如质量啊、轨道周期等啊，都产生了一定的关联。那么发现行星的方式呢，也从最开始的直接探测，转变到了现在观测宿主恒星，从而间接探测其行星。但是你们可以想象到，这些扰动是非常细微、难以被察觉的现象。那时至今日，仅有1颗系外行星是通过天体测量学方法，也就是测量恒星在天空中的位置所发现的。那其发现者呢，正是 Michel 和他的同事。不过这已经距离首颗系外行星的发现呢，有接近20年之久了。那我可以悄悄地和大家透露一下，专门用来进行天体测量的盖亚望远镜，使用上述的方法呢，发现了很多系外行星的候选者。那我会在后期视频中与盖亚的负责人一起跟大家聊聊这部分内容，那你们记得关注啊。接下来故事回到上世纪的70年代，既然天体测量在当时不可行，那还有什么其他方法可以发现系外行星吗？
But the technique we have used ourselves was the same idea. If you have a star, you have the planet like this, so you have a change of the velocity, not the position, change of the velocity. So the problem was to have an instrument precise enough to detect the change of the velocity.
而这种方法呀，又被称作为视像速度法。你看啊，宇正之前说了，我们跟诺贝尔奖还差一步之遥，而这一步啊，就在这儿了。我们都知道，恒星距离我们非常遥远，而且啊，它的距离越远，它的位置扰动我们就越难发现。可是，如果我们换个思路，不去纠结恒星的位置扰动，而是去观测它的速度变化的话，那么情况啊就会截然不同。我想你一定听说过这个例子：当有一辆汽车从我们的身边呼啸而过的时候，那么它的汽笛声音会从高亢变得低沉，这就是我们所熟知的多普勒效应。不过今天呢，咱们换种方法。你看啊，我手里正好有一个蓝牙音箱，我们就用它来模拟恒星的运动。首先，我们操作这个音箱发射一个500赫兹的正弦波，用它来模拟恒星发出的光。然后呢，我们把音箱固定在一个3D 打印的小盒子里，再系上一根长绳，让这颗恒星啊开始旋转。大家注意听。很明显，它的音调发生了周期性的变化。那如果我们把它的频率展开，你看啊，随着音箱周期性的转动，我们所接收到的声音频率也同样在发生着周期性的调整。当它向我们驶来的时候，频率会变得更高，而它离我们远去的时候呢，频率就会降得更低。同样的道理，如果这不是音箱，而是一颗恒星，它发出的也不是声音，而是一束光的话，那么这束光的频率也会产生周期性的震荡。这就是我们所常说的红移与蓝移。而更重要的一点就是，与测量天体位置的扰动相比，多普勒效应并不会随着距离的改变而改变，即便是这颗恒星距离我们十分遥远。当然，在实际操作当中也并非是如此简单。比如，地球对于太阳的扰动仅仅能够产生0.1米每秒的速度改变。所以，如果我们想要探测到一颗类地行星的话，我们的光谱设备的灵敏度就必须要达到这个级别才能够实现。
I've produced the first cross-correlation spectrometer in 77. It started operation, but it was with a precision not compatible with planet detection. Then after we had the chance, requests of the director of the French observatory to build a second one for a bigger telescope, and with all the different progress of technology, optical fibers, large CCD, and so on. So the philosophy of the instrument was the same, but with different kind of technical possibility. And suddenly, the precision of this new instrument jumped from 300 meters per second to 13 meters per second.
虽然13米每秒的厘米度不能让我们发现一颗类地行星，但是足以让我们探测到太阳系以外像木星一样的大质量气态巨星了。那由此，关于探测系外行星的革命呢，就逐渐拉开了帷幕。
We start the operation in early '94, and already a few months after, we have the first candidate. It was not certain at all. I have a lot of doubts because the first object we have discovered was orbiting with a period of only 4.2 days. And the theory for the formation of Jovian planet, big planet like Jupiter, predicts that the period cannot be shorter than 10 years. So 4 days to 10 years is about a factor 1000.
在此之前，还有几次来自于其他团队的误报。那后经发现呢，是因为仪器故障所导致的。此外，观测结果与理论预测不符，使得 Michel 面临着巨大的压力。
And it's the reason why I've decided to remeasure the same object the next observing season in '95. And in July '95, the star 51 Pegasus reappear in the sky. And we had only 1 week of in July of observing time. So every night we measured this object, and it was following exactly the same ephemerid as predicted 6 or 7 months before, the same period, the same amplitude, and the same phase. So it was enough to eliminate with other arguments, to eliminate the alternative explanation.
于是，米歇尔和他的团队发现了天文学历史上第一颗围绕着主星序恒星运转的行星。那根据天文学上的命名规则，它被叫做了飞马座 51b。飞马座51是宿主恒星的名称 ，B 则为该系统中第一颗被发现的行星。那这是一颗类似于木星的天体，距离我们50光年，轨道周期为4天，星体表面温度为1000度左右。那在镜像速度法大获成功之后呢，当时的科学家也在尝试使用其他的方式来发现地外行星，于是就有了凌日法。
Okay, the first surprise of this first discovery was the fact that you could have planets with very short period. So if you have a star here and the planet is very close, it's not improbable to time to have an eclipse or a transit. Simply, the planet is between your telescope and the star. So you cannot see the planet, but you can see a small drop of the periodic drop of the luminosity. And this was in 99, so only 4 years after the first one, we discovered an object with a period of 3.5 days, so very short period. And okay, we never know if it's a good target because it depends on the inclination of the orbital plane. And we gave this information to some of our colleagues in US working on Boulder, and exactly at the predicted time, they have almost 2%, not exactly, percent of the decrease of the luminosity. This was the first transiting planet. And very important, it was a very bright star, and immediately this called for the interest of this technique.
这场关于系外行星的革命渐入高潮，那不断有更多的天文台参与到了发现系外行星的项目中来。从一开始法国的尚普罗旺斯天文台和美国的 Lick 天文台，到后期智利的 LaCie 和中国兴隆天文台，那确认发现系外行星的数量也从最初的几个攀升到了几十、几百、几千。那由于天体目标观测策略的不同，也导致了一些天文台在这场科研竞争中脱颖而出。
At the beginning, we have a very strong competition between both teams, and The Americans have a big telescope, 10 meters, but only few nights per year. And we have a small telescope, but with a lot of nights, almost full, 100%. So we can see how many photons we were collecting and how many. But the advantage was in favor of small telescope because you have the continuity. When you have a planet with, I don't know, few months of period or something, and you have only few nights here with a big telescope, and then after you have few nights later, you see it's not the same velocity, but you don't have the curve.
那时至今日，我们已经通过凌日、镜像速度、引力微透镜等方法，确认发现了5000余颗系外行星。那这些方法可以帮助我们了解系外行星的物理属性。那它是气态呀，还是岩石行星啊？它的大气成分是什么呀？是否处于宜居带上呀？那奥马望远镜甚至还能解析出行星正在形成时的样子。开普勒太空望远镜目前已经确认了几十颗第二个地球，也就是说，这些系外行星都位于宜居带上。那在这些星球上呢，大气、光照、空气都非常适合生命的发展，是宜居或者发现高等文明最佳的地点。但是星际移民或者发现高等文明真的就有那么容易吗？
And I'm really active in this to contradict this kind of a lot of these ideas. I'm only given the same arguments. Okay, you know that the Milky Way is a big system, but the light will need 100,000 years to cross. So it's huge. So we search for planets, and we have discovered that almost all stars should have planetary system. So let's imagine we discover a perfect rocky planet at a good distance, a good temperature, so a perfect place for life. Okay. Now, and this system, let's imagine, is 30 light years. So 30 light years compared to the size of the Milky Way, it's really a neighbor. Yeah. It's really a neighbor. Mm-hmm. Now we have to compare to what the man can do. 50 years ago, Apollo 11 went to the moon 3 days, and the light need only 1 second to go. So you compare, this perfect hypothetical planet is 1 billion times more distant. No way to go. You have film, you have books, very nice to read on the fight between different civilizations. Okay, it's good to read, but it's nothing to do with science. Yeah. Announcement made that by Elon Musk that maybe in 1 century he dreams that maybe 100,000 people will be installed on Mars. But Mars has no good atmosphere, and it's not build an atmosphere is huge work, and then Mars is a relatively small planet, losing its atmosphere and so on. So, and what is the reason for that? To imagine the huge quantity of energy, money, and so on needed to do this kind of thing. For what reason? Because here it's relatively nice. Okay, maybe we'll have some problem, of the evolution of the climate, but in any case, it's a million times better. So for me, I'm really opposite to all these ideas.
通过与他的交流，我发现 Michel 的成功呢，并非偶然。那他早年非常喜欢研究电子科技设备，那博士阶段致力于探索天体动力学的研究。这些经历呢，都为他制作、研发高精度光谱仪和使用镜像速度等方法探测到系外行星埋下了成功的种子。那最后我问他，作为一名诺奖得主，作为一名天体物理学家，他对热爱科学的青年人有什么建议吗？
That is a huge country, China, And certainly we cannot expect too many astronomers coming from, and you have several more urgent questions to be solved. But if some of them, I would say, are good enough in mathematics and physics, I believe this is needed. Because presently, this is the tool we have. You need to have some facility you have to understand physics and to if you are lucky enough to have this situation, and you are curious, you are really motivated by. I don't compare the fact to be an engineer and to build a dam to collect water or to design a fast train or so. Mm-hmm. I believe it's extremely high level quality. So we need both, but evidently we are lucky enough that the field of science, not only astrophysics, but it's so fascinating. You have the privilege to contribute a little bit to the things we learn about the universe, to the chemistry, the brain, how the brain is working, how you can develop vaccine, and so it's fascinating.
在采访中 ，Michelle 对中国的科学发展评价极高。那他也和我分享了一个记者曾经问他的问题：如何才能培养出来优秀的科学家及诺贝尔学奖得主呢？
The typical time is 30 years between the discovery and the observing the, and eventually the discovery need to have a certain number of years before. So you have to compare the China 40, 50 years ago, and it's evident the situation was not like today. Yeah. So, but I'm sure as in a couple of years, the percentage will be increasing because when you are looking what is going on in China, it's beautiful.
好了，这就是这一期视频的全部内容了。那如果你喜欢物理，喜欢天文，别忘了加关注。我们下期再见吧，拜拜。